Thank you for opportunity to present part of result of our post-process work. The director of the project is postdoc Jarosław Źrałka and Wiesław Koszkul from Institute of Archaeology, Jagiellonian University. Today I will present, as I mentioned, part of result of our post-process work, which were done in Guatemala. Our site, like Piotr said, mentioned earlier, is located in northeast part of Guatemala in Petén region, in Yasha Naranjo Nakum National Park. Whole area is covered by high vegetation density rainforest. Our site comprises of two sectors, northern sector and southern sector. We are focusing now on northern sector, which consists of large plaza and several structures, north group, east group, west group, and also structure X, and some platforms. The vegetation on the site is different. We can find there high vegetation density trees up to 30 meters, and in some area we can also find small and medium vegetation. This is because the park is sometimes cleaned by workers from the national park, so the main area are regularly cleaned. But also the site is surrounded by high vegetation density, which we can see here. And for our analytic aim, we decide to digitalize northern part of the site. For that we have choose Terrestial Laser Scanning. Why Terrestial Laser Scanning? Because this site has something like 8,000 square meters, so 80,000 square meters, sorry. So it's not too big. And also for this area, ILS was too expensive, and flying with drones is non-effective, and also flying between trees is extreme. So we decide digitalize with TLS. Except ground surface and vegetation, we have digitalized also excavated feature. We have done during 3 seasons more than 800 scan position, which allow us to generate very accurate data. For example, also we can see here excavated structures, because we are providing excavation in few sectors, so we have also different kind of objects. For example, we can see here canal, steps from the Pyramid X, and also steam bath and chamber from the Pyramid X. All of those data from the ground and vegetation scanning, and from each excavated feature and structures, we have merged to one project. And for our analytic aim, we decided to generate classification of point cloud. We extracted ground surface, and we have obtained a very detailed model. This data allow us also for generating some kind of analyze. Like in this example, we can compare how the tomb chamber is located in the structures, but also those data were basis for creating very accurate digital elevation models. For example, here we have something like 1 million points per square meter, so it's very detailed, and except large structures, we can also examine smaller structures. Like, for example, here we can we can see Chultun is something like storage pits carved in limestone bedrock, and it has something like half meters. So we can examine smaller structures, and also we can examine much bigger, like tunnels in which we have steps. We can create section, and we can build whole database with those data. Also, we can focus on smaller part of our data. And for example, we can see here on the left side structure 82. This structure probably is scattered by main road, which is providing to the southern part of the city. Of course, many of those structures are or elements are normally not visible from the ground surface, so we have some opportunity to recognition some new elements. On the right side, we have our last excavated during 3 seasons steam bath. This is related with ritual purification. Sorry. Można tego film puścić? This is example of 3D model, which is also created from point cloud obtained mainly from laser scanning. We can, and color of this 3D model this color is from ambient occlusion map. This ambient occlusion map is a source of light map with which we can examine also some kind of structures or surface. With this structure is connected also with channel in which water was channeled outside to the south part of the complex. Next, all of those data were also basis for creating 3D models, but with game engine. Game engine is giving us some opportunity for building application with interaction. This is still we are still developing this, so the quality is not so good, but it shows how this could work. Also, we can compare some data from excavation with drawings, with text, and also we can switch to external application, like for example here RTI viewer, in which we are examining our surface, which is created only in 3D environment. We have we use for that mainly Blender, in which we have defined light source with intensity, with direction, and we have generated several renders, which are basis for creating this external file. With this, we can in real time examine whole area or selected area of the surface, and we can find some new feature or some elements which are normally not visible from the ground. And also we have generated normal map, which are vectors, surface vectors. And for example, here, this map very clearly presenting us some, on the top of this bastion, is presenting us two circles, which are probably some kind of structure, maybe some defense structures, we don't know exactly. But they are totally not visible from the Earth. Also, we can notice that we have lots of older trenches featured, which were not visible earlier. Also, even those roots which we can see here, this is good for planning further excavation. So, what is important when we are working in forests. Also, next example is one of the platform probably was longer and was destroyed. And here also we can notice two sharpened edges on east and west part of the edificial structure. This is northern group. So, conclusion. For sure, with terrestrial laser scanning, we are obtaining very accuracy data with high resolution. Like in our situation, we have 1 million points per square meter, but this also is creating lots of problems. For example, we have very heavy data, and even when we have a strong workstation, sometimes we have to decimate point cloud, or we have to split project to some smaller projects. For sure, benefits also is full control of scanning process. We can control what we are capturing. As we know, vegetation density, especially when it's higher, it's generating lots of problems with capturing. So with TLS, we can generate more scans, and we can capture as possible. We can capture ground surface. Of course, this is a good solution for small areas, not for 100 square kilometers. Also, complete merged data project, that we have full homogenic project with captured digitalized structures which are excavated with whole levels. We can, for example, during the scanning process in the field, we can break our work and we can scan something different, for example, some kind of levels of our feature, and then we can back. So we can continue. So for sure, this is benefit. With this data also we obtained various data, post-processing data, like we can generate drawings, orthophoto plans, maps, digital elevation models, 3D models, and what else we'll see in the future. And for sure, TLS is time-consuming process, so this is problem because scanner has some limitations. So we cannot, in some conditions, in some atmospheric conditions, we cannot digitalize. In the future, we probably we should participate in project which is now developed in Guatemala with Paculam organization foundation. We will probably get access to data from ILS from Maya land, from which is surrounding our site. So for sure it will be some new challenge for us, and for sure we'll get lots of new information about Mayan culture and our site. Thank you.